let's work a limiting reactant problem in chemistry. And a typical limiting reactant problem looks like this. If there are 10.0 grams of silver and 5.00 grams of selenium, how many grams of silver selenide can be produced? And I will give you the balanced reaction for this process. Now, we will do, through the course of the semester, probably 50 limiting reactant problems of various kinds. And so it's useful to be able to identify a limiting reactant problem. And the best way to identify a limiting reactant problem is going to be, can you find moles of two different reactants? If the answer is yes, then it's a limiting reactant problem, and you will use this approach. And the approach always says use both of the grams, or however you find moles throughout the length of this course, to figure out how much of the product you can make and see which one is smaller. The smaller amount of product is always the amount you can make. Let's demonstrate this. So, and I'm breaking the limiting reactant problem down into a number of steps that you will be expected to do all by yourself, breaking it down anyway, when you get to exams. 1, how many grams of silver selenide can be produced? If silver is the limiting reactant, start with the grams of silver. And we're going to convert grams of silver into moles. And we need our periodic table because silver is 107.9 grams per mole silver. That's 107.9 grams on the bottom. And 1 mole of silver on top. Okay. And in these types of problems, certainly the ones we're doing today and the next couple of examples, this first step always starts with mass in grams, and the next step, or the first unit conversion, is always a molar mass. Then the next unit conversion is always going to be a mole to mole ratio. Using coefficients. And what I mean by that is, in this reaction, for every 2 moles of silver reacted, there will be 1 mole of silver selenide produced. Like so. And then what's going to go over here is going to be, well, we want grams of silver selenide. So we need the molar mass of silver selenide here. And so the third thing is going to be, no, just change this to red, molar mass of silver selenide. And for silver selenide, I've got silver at 107.9 times 2 of them, plus selenide is 78.96. So 294.76 grams. And of course, I've got my grams on the top, and if I cancel everything, I've got grams of silver and grams of silver on the top and bottom. I've got moles of silver on the top and bottom. I've got moles of silver selenide, and this should be grams of silver selenide per 1 mole silver selenide as well. And I'm left with grams of silver selenide at the end. And I sort of run out of space. Maybe I should have started a little farther over, but I'll write my answer up here. So, but here's my numbers. I've got 10, divided by 107.9 divided by 2 times 294.76, 13 point, let's say 7 to 3 sig figs, grams of silver selenide. If silver is our limiting reactant. Now let's do the same thing if selenide is the limiting reactant, and I will start a little farther over this time. I have 5.00 grams selenide. Selenium, sorry, I have 5.00 grams selenium. Selenium is 78.96 grams per mole. So that's 78.96 grams of selenium per 1 mole selenium. For every 1 mole of selenium reacted, I will produce 1 mole of silver selenide. Again, this is new to us in this lecture outline, and this is always using the coefficients from the balanced reaction. And it's called a mole-to-mole ratio. And then we will have another molar mass, and it turns out this will be the same molar mass that we used in the last problem. And now we can do all of the math for this one. And I get 5 grams divided by 78.96. We don't need to put in the ones, times 294.76. Yep. And I get 18.7 grams. Now let's look at the whole sheet here. We can see that our smaller amount is the 13.7 grams silver selenide. On the next slide, how many grams of silver selenide can really be produced? The smaller amount. And we write this because it's our notes, but on the quiz or exam, you would be expected to box or somehow indicate 13.7 grams of silver selenide is the answer. It's always the smaller amount though. And next question, what is the limiting reactant? Well, the limiting reactant is whatever you started with to find the smaller amount. So silver is the limiting reactant. And then how much of the excess reactant is left over? Well, as we said before and demonstrated with bread and cheese, start with the 10.00 grams of your limiting reactant. 10.0 grams. In this case, 10.0 grams silver. And this is a calculation to figure out how much of our selenium has been used up. And I should say, find out how much selenium has been reacted away, but used up is another way of putting it. And then to do that, start with limiting reactant. Convert your limiting reactant into moles, just like here. Then we'll have, so let me write that. Then mole-to-mole conversion. This time we are going from moles of limiting reactant to moles of excess reactant. 2 moles silver are reacted away for every 1 mole selenium. And then for selenium, 78.96 grams per mole is the molar mass. Excuse me. And putting these numbers in, 10 divided by 107.9 divided by 2 times 78.96 is 3.66 grams selenium reacted away. And if you've done everything right, this better be less than the amount that you started with, because it's supposed to be the amount reacted away and since it's excess, it has to be less than what you started with. So then start with 5.00 grams of selenium, subtract the react away amount, which is 3.66 grams, and you're left with 1.34 grams selenium left over. Oop, get up there. And that is everything we need to know about limiting reactant problems for now.